Hello, everyone. Thank you for coming. Welcome to GTC. My name is Scott Ciccone. I work on the networking team at NVIDIA, and I'll be your host for today. So before we jump in, I'm going to try to do this very quickly. I want to give a few quick announcements. Don't forget to download the NVIDIA GTC mobile app for the latest updates, session catalog, quick and easy to complete survey, if you saw that on the board a few minutes ago. Tomorrow morning at 10 a.m. is our NVIDIA CEO, Jensen Huang, delivering the keynote at the SAP Center. It's just 1 mile from here. The doors will open at 8 a.m. And we recommend trying to arrive no later than 9:15 because it is first come, first serve for seating. The parking there is free. There will be shuttles running from the convention center here starting at 7:30 a.m. And don't miss the poster reception this evening from 5 to 7 in the Civic Center. You can join us for a cocktail, have a read through the posters and chat with the authors from around the world. Make sure you check out the GTC Park, where you're going to find art installations, lounge areas, food trucks, lunch service, and sponsor activations. And finally, the session recording will be made available to attendees in the session catalog within the next 48 hours and to the public at NVIDIA On Demand next week. And without any further delay, this session is titled Enabling Intelligent Storage to Process Data for AI Applications. And I'd like to introduce our two speakers today. First, we have Vincent Su. Vincent is an IBM Fellow, Master Inventor, CTO, and Vice President of IBM Storage. His responsibilities include IBM Storage Technical Strategy, Future Storage Technology Research, Storage System Architecture, Design and Solution Development. He leads IBM Strategic Storage Initiatives to support hybrid cloud, data and AI, and cybersecurity. He also leads the Infrastructure Architecture Optimization for watsonx. And joining Vincent today will be Rob Davis. Rob is Vice President of Storage Technology at NVIDIA's Networking Platform Group, where he focuses on high-speed interface technology for storage solutions. He currently leads development and marketing efforts for NVIDIA DPUs, data processing units, to optimize storage for AI and GPU workloads. So without any further delay, I'll hand it off to Vincent.
Well, thanks everybody. I'm glad to have the opportunity to give the talk with Rob here. Okay, so let's just get right into it. So before the presentation, I'd like to emphasize the long history of a collaboration between IBM Storage and NVIDIA, and from the early day of GPUs to today, we're going to talk about this. We are announcing there's something called IBM Content-Aware Storage with NVIDIA NIMs. Okay? So I'm sure that many of you heard about this phrase called data is the new oil, data is new gold. It is our belief that the competitiveness of the enterprise really depends on whether they can successfully using AI tool to harvest the insight of the gold, of the oil, of the data. But the thing is that today, if you look at the Gen AIs in the market, most of the data, they are very, very successful to harvest the insight from the public data. There's a common crawl to go through the internet, to go all the data. But the enterprise data, there's only small fraction, actually. We believe there's less than 1% of data in enterprise actually being used in the Gen AI. And there are lots of reasons of that. So next, I would like to get Rob to talk about, from NVIDIA's point of view, why is that?
Thank you, Vincent, and also thank you for inviting me to join your talk here. So if we look at data centers, traditional enterprise data centers, and we compare them to AI data centers and the applications that run in each, you notice there's some major differences. First of all, in a traditional data center, and with its applications, the data is basically stored or written and then read. There's not a lot of read and write going on. Now, obviously, the There's databases, and those do a lot of reading and writing, but in general, the applications are write once and read often. The second thing is that the data is compressed. Remember back in the days of hard drives, we didn't compress data, but with SSDs, they're expensive, so we compress the data. And thirdly, the access control, and I'm not talking about the hackers, obviously that's very complicated how the protection is for that, but just the general user access control, you either have authorization to read a file or you don't. It's very simple. If we look at the other side in an AI data center, running basically inferencing applications is what we're going to talk about today, there's a lot of differences. First of all, it's generative, right? So the data that you read in for the process, in this case RAG, you have to uncompress it, and that goes into the general storage, the general high-speed storage, but you've already got a 3x increase in the amount of data. Then you add to it the KV cache and the vector database, and you can expand. We've seen in some of our labs up to 10x increase in the size of the data, just moving it in for inferencing with RAG. Now, all this data increases the amount of memory you need. So you have to keep in mind that if you want to have high performance of your inferencing application, you need to have enough memory to make sure you get the efficiencies you need and you're not doing a lot of shifting in and out of hard drives, of SSDs, I mean. And then the biggest issue is the access control, because there's no file, the connection to the files goes away once you load all this data into the inferencing engine for RAG. And with that, I'm going to turn it back over to Vincent, who's going to go into details of how IBM has worked to solve some of these issues.
Thank you. How many of you can raise your hands are familiar with the RAG process? I'm sure many of you probably are. Okay, good portion of them, or you. So let me just briefly go through this process, so bear with me. Again, I'm sure that some of you have a very fancy implementation, but let me just show you how people do it in general in the enterprise, right? So first of all, customers don't have all the data in one place. They have data sprinkled in multiple different data storage silos. So often what people do is they go copy those data from whatever the original data source into some form of data lake or repository. Then they send this data to some place to do data processing, basically transform the data from the raw data, like PDF, chunk it, parse it, and vectorize it. Then they store the chunks and vectors into some form of vector DB. And that's where the people can start doing the search and similarity search and all the stuff. Remember how many times in my sentence for the last 30 seconds, I talk about making a copy of the data, right? So when we work with our enterprise customer, we notice they are copying the data everywhere, right? Easily, one copy of the data into 5 copies of data. Well, that's great news for the storage vendors, but it's really, really inefficient, right? It's very, very high cost because not just the replication of data, also the networks and all the stuff. And more also, there is a very inefficient because all the data being copied from one place to the other ones, then they sort of lose track of what data has changed. So in general, when I see customer, they just do everything start from over again every so often. Every week, rebuild the vector databases. Every month, redo this, right? This is very, very complex, inefficient, and very costly. And why is that? Okay, I'm in storage business forever. Let me tell you, from my vantage point, we have this belief that storage only deals with bits and bytes. Storage device, storage system know nothing about the content of the data. To us, a bit is bits, a byte is bytes. This one is your financial statement. This one is your X-ray. By the time you get to storage, they are all equal. There's no difference. Not like this byte is more important than that byte. Okay? For the last decades, there's several decades, storage innovation is focused on cost performance optimization, scalability, consumability, securities, reliability, availability, all the stuff. right? Which is very, very important. But you know, we never really have this, we always have the aspiration, a dream that what if storage can actually understand the content? Would they facilitate, would they make these things better? Would they make the world better, make the world more efficient? Today, the reason why in the previous page I told you that we copy data from all over the place is because none of the storage infrastructure know anything about the data. In order to process data, you need to move the data from location 1 to location 2. This is the old concept called bring the data to AI, right? I have a GPU cluster. In order for me to process this data, send me all the data, then I'll process it. The new way to think about that, what if we integrate those AI capability in the storage? So storage fundamentally know the data. It brings a lot of promises. So you don't have to copy data everywhere because the storage already know. Today you ask for storage what? Give me the file, give me the block, give me the objects. In the future, you can even ask storage. Give me the token, give me the vectors associated with the file and object. The other problem is today in unstructured data, file and object, unless you know the URL or the file paths and file names, unstructured data is pretty much unsearchable. Unless you tag the data ahead of time, and you put all the tag in some sort of databases, and you know, later on you can search the tag. But what if you didn't tag it 10 years ago? You don't know what to tag. Well, there are two ways to do it. One is you have a time machine, go back to 10 years ago to retag it. Until that things happen, then you just need to bring all the data to the server and memory and then research it again. But there's a better way to do it. Why don't we integrate those Gen AI capability in the storage to make storage better? And that is the essence of a content-aware storage we are announcing today. So there are 4 major components to build content-aware storage. Number 1 is the intelligence, right? We talk about the ability to understand the data, the content, and be able to process it, and then be able to turn from raw data to the vectors and tokens to something that we can process. Second, all this process is done accelerated by GPU. Number 3, you need to have an AI optimized storage. This is not just some, any storage will work. Sure, any storage will work if you don't care about money and time, okay? Number 4 is VectorDB. You need to optimize the VectorDB, and you need to bring these things as integrated systems. So today we are very happy to share with you that our collaboration with NVIDIA, the data processing pipelines and hardware acceleration, we're leveraging the NVIDIA's technology, and I have Rob to tell you about this number 1 in data processing pipelines.
Thanks again, Vincent.
This is very tricky to make sure that we don't bump into each other.
Do a little dance. Okay, so at a very high level, here's the pipeline, and we're going to talk about where the NIMs, which is the software that Vincent was talking about, and the GPUs that they run on, fit into the pipeline. So at a super high level, you have the data that Vincent talked about that's unsearchable on the left, and on the right you have an inferencing engine. In the middle sits this RAG appliance. Now, I'm calling it a RAG appliance. It doesn't necessarily have to be an independent box. It can be integrated into the AI data platform, the inferencing machine. So let's dig a little deeper. And what that RAG appliance does is it's basically watching all the data coming in and searching the metadata and figuring out how to use that knowledge now on the data to accelerate and make more reliable the inferencing answers. So this looks super complicated, but bear with me. And those of you that are familiar with RAG will know what I'm talking about fairly easily. So in the middle here is the high performance storage where you're putting the answers that you get by sort of pre-processing this data or adding metadata to it. In the bottom, or in the top left, I don't know if there's a pointer on here or not, but anyway, the top left is the actual data you're feeding into the system. There's a proxy agent there that basically mirrors it in 3 different directions. So the first is just the regular content. Then you've got the knowledge graph, and that goes into a KV store. That's the middle there. And then on the bottom, too bad there's not a pointer here, but on the bottom where it says Nemo and better, that's where you're building the vector database. So you now have 3 different approaches that then, as the query comes in the bottom left, you get results from searches on both the KV store and the vector database. And those then feed into the enhancer, which basically takes that query information that's going to go to the large language model and enhances it to get better results. And then that goes to the large language model, and then the guardrails make sure that the data you're about to present to the inquiry should be presented to that inquiry. So if we've put the NIMs on, these are all places the GPUs are running in this process, and the different NIMs that we'll go into more detail on in a minute are providing those functions that Vincent was talking about. And on top of all this, so you know where to put them, we have something called a blueprint. And the blueprint in this case that IBM leveraged was for RAG, but we have blueprints, and I'll go into a little bit more detail on that in a minute. We have blueprints for all kinds of different AI applications, lots of them. And there's actually going to be presentations, if they aren't already ongoing, on just blueprints and just NIMs if you want to dig into a whole lot of details, like a whole presentation on. And what the blueprint does is just provide kind of here's a potential way you could put all these together to do RAG, but it isn't set in stone. IBM, for example, made all kinds of modifications to it to integrate it better into their systems and the ability they have to look into storage along with it. So let's look at what NIMs are so cool. What's so cool about NIMs? So if you look at how you would go about doing an AI application in your data center, you have 2 approaches. You can actually not even need your data center and basically use a cloud service and do your work. But there's some disadvantages there. It's fast. All you need is a credit card, probably a really deep credit card. And it's fast because they've already done all the work for you, but it's not very customizable, right? You get what they did. Here's their RAG, this is how you get it. The other thing about it that makes people nervous is you have to give them all your data. So all that data you have that you need to figure out how to put metadata on, you have to send it all to a cloud somewhere and hope they keep it safe. The other thing you can do is do it yourself. Hire a bunch of people. First of all, it's kind of hard to find AI people right now, but let's assume you could hire them. You start working on it. You've got a development cycle you got to work through. And if you don't have the people, you have a big learning curve. So that's where NIMs come in. They kind of give you the best of both worlds. So the NIMs were developed by us. They're microservices, so they're just containers, so they're very portable. They're very easy to use. You get to support from NVIDIA on them, and they're high performance because the people that put them together have been doing AI for a long time, and they're very experienced with it. They're in wide use. Besides IBM, this is just some of the names that other customers that are using them or partners that are using them that I could fit on this slide. There's actually, multiple slides of people using them. They're widely distributed in the industry. And then the blueprints. So what the blueprints do, as I said earlier, is they show you how to connect these all together. And there's all kinds of institutional knowledge because we wrote these NIMs, we use these NIMs internally. So we're very experienced in how to use them and put them together. And like I said earlier, there's hundreds of different applications that we have blueprints for. And the one that IBM is now going to show you more details on was obviously the RAG one. And I'll turn it back over to Vince for those details.
Thank you. Next one, I want to spend some time to talk about the AI optimized storage. Okay, we have been working with customers. So first of all, the number one problem the customer has is that Rob talked about early on in terms of the ACL issues, the security issues, right? In multi-tenant environments, that let's say that in the storage that Rob has a certain set of files, I have my own files. We are not supposed to see each other's files. Unfortunately, today, in a general practice on RAG, I keep talking about general practice. I'm sure that some of you have very fancy ones. The general practice, they pick up all the data between Rob and myself, and then run through the pipeline, put in all the vector into the vector DB. By the time it becomes vectors, forms, they completely lose track of the data coming from where, the chunks come from where. So guess what? Even though somebody doesn't have, like me, don't have access to Rob's file, but I can ask the questions, and the chatbot can actually get the knowledge from Rob's files and answer the question that I am not supposed to know, right? So that's the big problems. So when customers tell us that before you do that, you got to make sure that the derivative, we call it derivative of data, like vectors and tokens, are corresponding to the raw ACL for the raw data. Okay, that's number one problem. We say, got it. That's why we have this, secure file system to make sure that we can do this mapping very efficiently. Secondly, our customers say, when I was talking about the container-aware storage, all my customers are very excited, right? Now it's no longer a black box. Our customer has exabyte of data in an enterprise data center. Many of them just hoping that nobody ever asked them to find those informations, right? So, but now they say, it's great. And then the worry come in. Wait a minute, Vincent. Do you mean that in order to use those fancy technology, I need to move all my data from the old storage, from whatever it is, to this new storage? Again, great news for the storage sellers, not good for the customer. In the storage world, we call it rip and replace. It's a crime, okay? You don't want to do that. So we'll say, no problem. Our technology will allow you not to move data at all. We basically can abstract, virtualize your existing legacy storage. Your data is the file storage, object storage, or HDFS storage. You put our storage software on top of it, we can virtualize them. So we're going to do that. Good, second problem solved. Now they were like, hey, remember we just talking about today, RAG is mostly a batch process, right? People just gather a bunch of file, run through that. That would be great for NVIDIA's business. People processing the same data every day. You really don't want to do that, okay? Because we can use the GPU to process more complicated information, complicated data. So in our storage technology, not only we can virtualize the external storage, we actually can pinpoint and monitoring what data is being changed. In the external storage or internal storage, we know what file, what object being added, deleted, updated. So we basically pick up those updated change entities, run through the pipeline. So think about this, right? If you only change your data 5% a month, that means we only have to reprocessing 5% of your data versus in the past that you reprocess all the data all the time. No problem. We get this solved too. We have that technology too. Okay? Last one, all this new innovation about NIMs, the data processing, all this stuff, need to be GPU optimized because people are using GPU to accelerate that. We actually have a great accelerations for the GPU, from GPU direct to all this technology. So that's why I'm saying that you need to have AI optimized storage as the base for the container-aware storage. And let me put those things together. So today we are announcing IBM container-aware storage. Our project manager, Patrick Faye, is sitting in the back here. So make sure I say the things right. That we will be the first one integrating with NVIDIA's multimodal PDF extraction blueprints and with the NVIDIA NIMs in the IBM AI storage. 1, 2, 3, 4, 4, so all 4 things put together as the software packagings. Okay? So this is our first delivery today about our container-aware storage software. We integrate those capabilities, and then those blue line you may not know exactly what it means, but that's okay. Those are IBM capability. Underlying the storage, we use IBM storage scale as a high-performance storage and GPU-optimized storage, and also the virtualizing capability. And we create those IBM CAS data services data service to allow us to be able to integrate that with the NVIDIA's pipeline and all run on OpenShift as single packages. So as I say, that we'll be the first one take this to the market. And what's the key value proposition of this capabilities? I know there are a lot of companies talk about this. Number one is simple. We spend our time to integrate those blueprint, those innovation, and the storage into one single turnkey solutions. Second one is efficient. Remember, I'm talking about two things. Number one is you don't have to move your data. Data can sit in place in your legacy storage. Number one is we can do incremental processing of your data. The third thing is secure. This, if you want to get into, remember we were talking about why only 1% of data being used in Gen AI, in the enterprise for Gen AI. Because of this reason, because unless you solve the security problem, people are not going to, the enterprise is not allowed to adopt your technologies. And in the summer, we are going to deliver the turnkey solution. We put all this thing together, including NVIDIA's NIMs, NVIDIA GPU with the IBM storage, and this is called a Fusion SCI, is a hyperconverged infrastructure appliance into that in this summer. Of course, when I say summer, people say, well, Vincent, you are from Arizona. The summer can be November. So no. This is going to be somewhere around May or June this year. And we want to have this as a turnkey solution. As I say that during our survey, we know some companies are very sophisticated. They will have the infrastructure layout. They just want to drop in NIM, drop in IBM storage, a software package, and get it go. But another spectrum of customer, they are dying. They only know they have a lot of data. They want to turn their data into insight. So with this kind of architecture, we take care of all the packaging, all the optimization. The customer, only thing customer has to do is just point to me where your data you want me to vectorize, which data you want to process, and how often, do I need to monitor the things, and there's very few clicks that you tell me what you're going to do. From that point on, I keep track. When I say the system CAS keep track of the consistency with your vector DB, with your ROS data. From there you go. You don't have to deal with that data science's black magic anymore. You just enjoy the benefit of that turning your raw data into insight. Okay? You know what? I'd really like to show the demo here. We have a demo, get ready. Show that three aspects of how it's simple, efficient, and secure. The leader of the demo is Joe Dan. He's sitting right here. Joe, raise your hands. That we are going to have this demo running at IBM booth later on. So tomorrow, you guys are welcome to go to IBM booth to see this demo. You can get your hands-on experience to look at that as well. By the way, again, I want to make sure that you know today we are announcing the GA. This is not a vaporware. We are working with Lenovo Everscale AI. We are putting the IBM content-aware storage scale softwares on Lenovo is a part of the Lenovo Everscale AI offerings. Okay? Okay, I want to conclude this presentation. I mean, Rob and I know each other for a long time. We have very tight collaborations on all area of this, NVIDIA and storage. Today, we're just talking about the content-aware storage with NIMs, which I hope that you find this presentation exciting. It's very exciting for us. We have been working with NVIDIA on GPU direct storage. It's very, very exciting that technology will continue to push this technology, go beyond the Gen 1 of the GPU direct. And right now, we are collaborating on the S3 RDMA, the Q object. Basically, it's RDMA enablement. Today, RDMA doesn't exist in S3 protocols, only in the FHIR protocols. So we are bringing that to the S3 protocol, and Guy Markley in the IBM team is leading this effort. And last one is the DPU process. We have lots of projects on the DPU. One of the projects we are working on before is, Rob, remember this? It's our ability to allow you to perform the encryption at a host level, but still allow you to be able to perform the data reduction, such as deduplication and compression. We're applying some magic software in DPU, and we'll take advantage of all the DPU capability. And we also, in the summer, we will have this DPU running our scale file system to attach to external JBOD. We're exploring those DPU capability to improve overall infrastructure efficiencies. And last, I want to encourage everybody to visit the IBM booth. Besides, you will see the demos. The most important thing is right next to the beer gardens. So if you're a couple of beers, everything looks better. There are a lot of exciting talk, and then the demo over there. I really encourage everybody go to there. So we still have like 10 minutes left. Rob and I would like to open up for Q&A. If there's anything that you guys are interested in, we can be here to help answer the questions.
Hey.
Thank you very much. So when the data processing happens in a parallel file system, for example, if you have like a AFM and you have to mount it into GPFS and you the processing. So your turnkey solution, what kind of parts it has, so the parallel file system can also benefit from that.
I'm sorry, I missed the last part of the question.
The integration with the parallel file systems.
Yeah.
Like you would not do parallel processing on the machine you showed. It'll be somewhere else, right?
We will do the multi-processing because that's take advantage of the GPU multi-thread capabilities. We will need to, part of the reason why we choose this file system is because we can support all the parallel processing GPUs. Is that what you're saying?
Like high performance computing, for example, HPC.
Yep.
So you wouldn't have this as like you would mount it somewhere else, like GPFS, right? Or how would that work?
Let me do that. I think that, let me spend more time with you after this talk. I want to make sure that I capture your question. Okay, next one.
Question?
So if I understand you correctly, the vector database is a component of this context.
Correct. We integrated
storage.
VectorDB as part of the CAS offering.
Right. So one way to think about it is, so if you imagine a vector DB, it's like vectors and then text content and maybe a little bit of metadata. Mm-hmm. A way to think about it might be like okay, you don't have that text, but maybe you have the range within and a pointer to the source document and an ACL all in that vector database. So then you can incorporate that in the searching and retrieval.
Okay.
Does that make sense?
It makes sense, but let me just show you the complexity here. If you just simply mapping all the ACL of vector back to the file, if somebody that decide tomorrow I walk in, I want to change all my file name, I can easily create a storm to update all the vectors. So we have a very clever way to how do we address that by leveraging our file systems. So you will not see those problems. Next.
But that must be secret to IBM.
It's a patent. We have to make some money, okay?
So, as a customer, how do you help us size the solution? So for example, if I needed more compute to run the NVIDIA NIM services, do I need to buy extra storage that I might not need, and also vice versa?
Nope.
Need more storage?
Nope.
Can you tell us about how that works?
This is truly, you can do an independent scale, but I want to first admit, we are still searching this area. We have some idea, like you want to process how many documents per day and how big are your documents. We have some idea, but we don't have a precise tool to do that. And that's something that we can.
Well, remember the NIMs are microservices, right? So they will scale. It's just a matter of how they decide to integrate that scaling into the solution, CAS solution.
Ideally, we want to tell people that you don't have to even worry about that, right? We can detect your size volume and send you a build to say you got to buy more NIMs and buy more GPU, but we are not there yet. Right now, we have a certain somewhat kind of fixed configurations. Actually, I shouldn't say fixed. The base configuration, you can scale from there, right? If it doesn't fit your need, then we will help you to scale. But this is one area. Again, this is all about consumability. People doesn't want to take time to do this. They just want to do answer the question things, right?
This may be that I don't know enough about NIMs, but often your chunking and embedding strategies would differ based on data type, class, etc. Is that easy to configure for like different types of files, that pipeline?
NIM has a very rich library and process all kind of. In fact, I want to emphasize this. Today we announced this integration with NVIDIA NIM is the first in the market to be able to do multimodal. Not only can practice text, can practice table and charts. Okay, when we first this journey early last year, a year ago, we only have text tools, and we find out that even though applied to even IBM field support, a lot of information buried inside the tables and charts. So thanks to this capability from NVIDIA, we have ability to understanding those assets. Right?
So to expand on that a little, the NIMs are getting more and more features all the time, like Vincent was talking about one. So I would suggest our website is very rich. If you Google NVIDIA NIMs, you'll get a page that goes in multiple directions depending on the application you're looking for. And also I would suggest, I believe, and Scott may know more, there's going to be some talks here just on NIMs by the NIMs teams.
Cool.
We're from the storage team for obvious reasons, but you'll get to see the whole spiel on just NIMs.
Awesome, thank you very much.
Yeah.
So again, I want to admit that this is very, very new. This is my lifelong dream, if you will, to turn storage from dumb storage, only know bits and bytes, to content where the next generation of computational storage. So if you visit IBM booth, we will have a QR code there to ask your help. Please help us. If you are a user of this one, what kind of API, what kind of user interface, what kind of things are important to you, right? A lot of things we learn how to design this because we're working closely with our customers. So help us. This is the new evolution or even revolution of the storage industries that collectively, if we make this better, I think that we can use our resources more efficient.
And from our perspective at NVIDIA, we're super excited to be able to integrate the GPU technology, the AI technology into storage. And that's why we're partnered with, we have lots of storage partners, but that's why we're working with IBM in their CAS application.
Any more?
We have time for one more question.
You mentioned computational storage. Is that in the drive processing?
I'm sorry, I mentioned
Computational storage.
Computational storage.
In the SSD, you mean?
Yeah. Are you computing in the SSD?
Oh, okay. Computational storage, the concept of computational. So first of all, IBM has it's called the flash core modules that we put a very advanced, flash technology in the drive, as well as dealing with encryption and compression. And last year we embedded the ransomware detection logics as a part of SSD. So this, I always tell people that this is value chain. Every layer will try to maximize their value and the capability. I absolutely, where it fits, we should have those computational storage and SSD layers. The only some kind of disadvantage here is when you start talking about a context or content, the drive level is harder to do. Mm-hmm. It's probably better to be on the higher level. But for a lot of localized operation, SSD is perfect, like compression, deduplication, or ransomware data pattern assessments. Those are perfect. All right, thank you, everybody. Please come visit IBM booth. Give us the feedback. Thank you.
All right, thank you, speakers. Appreciate it. Thank you all for coming.